All right, good day everyone, and welcome to today's Accendo Reliability webinar event. We're going to talk a little bit about teaching and how you, as a reliability professional or an engineer or a technician or whatever your role, we often find ourselves teaching others. And so there's a lot to that. It's not something that we learned in school is how to teach. We were taught at, so to speak. And yet we're on the other side of the realm at this point. So let's see if we can sort that out and go forward from there. Now I do have a whole pile of links for you, and I'll bring those up near when I talk about the other references and so on. But feel free, as many of you are doing so far, 85 Fahrenheit in Mumbai. Yeah, that's nice. But please do use the chat window and feel free to answer each other's questions or comments and so on. That's what it's there for. I'll keep track of it as best I can and address things. We will be looking to the chat window for lots of discussions, and I have a few of those coming up, and that should be a lot of fun. Also, I'll keep track of the Q&A tab as best I can. We often face questions when we work with other people, when we interface, the technical word there, when we work with other folks, they often have questions about reliability. All right, we're going to say, oh, that looks like that may lead to galvanic corrosion. And they go, well, what's that? And we explain the dissimilar metals and a little bit of moisture with current through it, and so on, and maybe even give them some more information. Yet we face questions also of, well, how long will this product last, or what's going to fail, or how important is that failure mechanism? Questions that are related to what we're supposed to be doing and providing information and reports and predictions and estimates and so on about. One of my favorite questions is, well, how many samples do we need, right? That almost always leads to a discussion back and forth about, well, how many do we think we need and why, and what are the trade-offs? And we start talking about statistics and sample size relating to the population, and now we're teaching. Now we also have opportunities. There's things that come up in the course of the day and in the course of our working with product development teams or operations teams in a factory that present themselves that we can see as an opportunity to improve the reliability or availability of our system. We may be able to see cost reduction ideas, ways to optimize things, ways to improve things. And that's true of most any engineering discipline, right? We have the ability and training and background and experience to identify opportunities. And oftentimes, we need to make a pitch. We need to explain that to other people so that they understand what we're seeing and the opportunity it presents. In many regards, at that point, we're teaching. We're working on the very same set of tools and techniques we're going to talk about today. And then other times we create presentations or reports, or we're providing answers in a more formal way, and then we get questions, or we see opportunities, or others see opportunities, and we are trying to elaborate on what we're talking about, breaking it down so that it matches the audiences, the people that we're interfacing with, what they need. And so we can call it explaining. Yet whether we're addressing questions or presenting opportunities or just discussing what we're doing, those are all teaching in one regard or another. Now, you might have gathered here that I'm not really talking about let's get in a conference room or in a classroom and sit down and have a lecture. That's a form of teaching that we've seen and most of us have experienced in one form or another. Yet, that's not the only one, and it may not be what we would want to do on an ongoing basis. So learning organizations, it's a term I first heard about in the 80s, and I don't know how popular it is anymore. Yet, how many in the chat window do you have a place where it's a good place for learning for people who are asking questions and teaching each other on a regular basis? And that's kind of a loose definition of what I would call a learning organization. So think about it for a second and then type in, do you have this already, or is it, that's not happening? What kind of atmosphere or culture are you in your organization? Is it a place that others are learning and you are learning too? Learn by doing culture and the sharing. Good, thanks, Michael. Hallway discussions, yep. That happens all the time, Sanjay. Yeah, you're doing the lecture type thing there, Micah. Hopefully you get a lot of the other discussions and hallway stuff and everything else too. I don't know, formal, Carlos, it doesn't have to be formal or structured. I'm going to talk a lot more about that and really focus most of this presentation on it. Part of a mastermind group. Excellent, John. Yeah, that's a great way to learn. Yeah, and Dan, that's an issue, right? And it's something that we can address by doing and demonstrating and encouraging. That if somebody, I love the quote where somebody says that the only reason they're not arguing with the other person is that, and appears to be listening, is that they're just reloading for their next round salvo of arguments. Yeah, excellent, Lori. So a few of you are getting that in various degrees, and some are struggling with or have different kinds of cultures in it. And I love it, right? It's a wide range that's out there. Mentoring, Bart, that's it. We're going to talk about that briefly. And yeah, and Gregory, are we talking to non-reliability folks? Yeah, oftentimes that's, I think one of the things I hear over and over again, and at the RAMS conference I heard it some more, is that we're often lone wolves in our organization as the reliability professional or reliability engineer or reliability manager. And so those, oftentimes what we're bringing to the table is not common walking knowledge with the people that we work with. And whether or not you're the individual or not, that challenge comes up. And it's the same for an electrical engineer talking to a software engineer, right? There's plenty of cross and back and forth and between people all the time. And that's just normal, all right? And then, yeah, conferences say it. And yeah, training, I mean, it runs the gamut, doesn't it? There's formal classroom training, there's ongoing discussions or brown bags, get-togethers that are more informal. There are so many ways that we learn on a regular basis. Now, what I'm going to focus on is more of the way that we learn on a day-to-day ongoing basis with our peers and with the others that we work with, right? There's a lot to it when you start getting down into the details about what we do on a day-to-day basis. All right, so I'm trying to find the mute button here for a phone that just dialed in, but didn't see it. All right, so we end up in a day-to-day basis with teachable moments. We have opportunities, like I said, to answer questions. We use that as one of the examples. And we do this with individuals, with small groups, and informally. And so I'll outline a few of these real quick. Yeah, Gregory, hardcore reliability presentations. I hope you don't consider mine hardcore reliability presentations. This one certainly isn't, because I don't think I really talk about it other than in examples. Now, we recognize those opportunities, those teachable moments when somebody asks us a question. So, like just the other day, I was working with a client, and one of the junior engineers asked me, so what is 5 whys? You mentioned that the other day in a meeting. What is 5 whys? And so I explained it's a technique for getting to root cause. It's a way to push back or to peel back the causes for how something happens and what's causing something to happen. Now, sometimes when we're working with individuals in a meeting or even one-on-one, or especially one-on-one, they say, I don't think that's going to happen. Or I'm in a meeting negotiating for sample size, and they say, well, you can have one sample, but don't break it, right? And then its pushback is on a discussion of, well, they want to know how long their product's going to last or what kind of margin they have. Sometimes people just are confused. I'll say, oh, we need to do a physics of failure analysis of that failure mechanism. There may be a formula for that. And they look at me and furrow brows and say, well, what's physics of failure? Those are teachable moments. Those are opportunities for us to teach, to define things, to explain processes, to help them understand how to use those tools to make better decisions. The trick here is to not just talk all day, right? Is to really, really understand your audience, that other person. And there's 2 reasons for this. One is they have just provided you with an opportunity to help them understand something, for them to make better decisions, for them to do their job better, right? And a byproduct of that is that we can do our job better. So the piece here is to understand your audience, is to understand what technical depth they have, what do you know about them concerning the reliability stuff we're going to talk about. What can they build on that they already know and do? So if I'm asking, somebody asks a question or acts a little bit confused about physics of failure, and I know that they've done accelerated life testing in the past, right? Well, a technique is to start with that, saying, remember when we did the accelerated test and we had that formula that converted it from accelerated conditions to use conditions? Well, physics of failure is like that formula. It's a model of, and then we go on to describe it in some detail. So building on what they know already. But also keep in mind that, and I find myself, even when I'm doing these podcasts, especially when I'm doing podcasts, but even when I'm doing webinars, is that I want to grab a pen and explain something with a whiteboard or with a piece of paper. Getting it visual often helps, especially for more complex things. But sometimes the question really only needs a quick definition, and then they go, got it, and then stop. You don't need to answer it anymore. You don't need to teach everything you know about physics of failure. You answered their question, let's move on, right? So a part of teaching in this realm is to, especially when you're asked a question or you're working with an individual one-on-one, even in mentoring. I think it was Gregory, no, it was somebody else who mentioned that they were in a mentoring program and loved it. I don't see it right at the moment. That a good mentor will ask just the right questions, or will prompt just the right feedback, or will look for what you're struggling with and help you with that. All right? And so that's one-on-one, but they use a range of different techniques to actually help you move forward. Now, the key part on one-on-one interactions and teaching is that you have that person right there with you, or on the phone, or on a video call, and you need to look for those cues. And the easiest one by far in all of those circumstances is to ask, right? Building on that physics of failure confusion, and we talked about a previous accelerated testing and the modeling and so on, did that answer your question? Is all you need to ask. Is that helpful? Can you go forward with that? Yeah, calculus on the whiteboard. Yeah, don't scare them with the math. That's, at least let them have their first cup of coffee, Jay, so they don't get too out of sorts. Yet you need to start with where they are and what is it they need to move forward with their understanding of a question. Right? So part of what we're trying to do is to help them move forward. But the second part, which I think is as or more important, is that you're a good source for questions to be answered. You want to build on the trust. You want to build that you're the go-to person for topics like this, right? It's part of building a brand, for the lack of a better word, around your role as a reliability professional, right? It's not that you do it yourself. If the question is on physics of failure and your answer is, well, don't worry about it, I do that, and I'll take care of it, doesn't help them understand what it is. But second, it doesn't help them understand how to use that information once they get it provided to them. And third, I think more detrimental, is that you didn't answer their question. You didn't help them overcome some confusion. So why would they ask you anything in the future? So by answering questions and by clearing up confusions and by paying attention to what that person needs to move forward, and then stopping, is that they get value and they seek you out in the future so that they can continue to receive value. And that's a great spot to be in as a reliability or quality professional, or virtually any engineering professional. And so answer the question, pay attention to what is helpful to them or not, and then third, stop. Don't go into lecture mode, and many of you know I love talking about reliability stuff and can do it all day long. And I've had to learn to stop and then ask, is this helpful? Did this answer your question? Do you have any other questions on this? Are you good to go? Something like that to let them move forward. Now, in some occasions, and I've been in so many different meetings with so many different people, and they look at me and go, what is a reliability prediction? Or how good is a reliability prediction? One of my favorite topics. Or they say something about MTBF and I jump, say, well, that's not useful. And then they say, why? There's a teachable moment. It's not my meeting. I didn't call the meeting. It might not even be on the agenda, right? Yet there's a teachable moment. Same as with one-to-ones. It's understand your audience, answer the question, stop. Don't take over the meeting unless that's where the meeting wants to go, and unless you get that permission to do more. Be concise and clear. Now the challenge here is that if there's 3 people in the room, there's 3 different starting points in understanding and background for them, right? Now, having a discussion with just the person that asked the question or looked confused is missing the opportunity to also teach the other 2 people and bring them aboard. They may be more experienced or less experienced, and that's what makes it really difficult. But as you answer the question, be aware of the rest of the participants in the meeting as to where they're standing. Are they bored or are they confused? Bored is, you're done, right? Let's take this offline. If they're confused, maybe you need to explain it in a different way or in a more basic way, or maybe avoid the calculus on the wall at that moment, but take it to what would help that group move forward and make a decision or understand the answer to the question. And so the hard part here is that there's more than one starting point with the people you're dealing with, and it's not your meeting, right? If you immediately convert everything into a classroom exercise and pull up the slides and take over the presentation for 10, 15 minutes, they're going to stop asking you questions because there are other things and other reasons of why they got it together in that meeting. So the challenge here is to, as with one-on-one, is add value and then stop, is to create that trust that you're a good resource to help them move forward. So it comes back again to understanding your audience and where they are and helping them to be more successful with what they need to do. So hopefully you're detecting a bit of a theme here. Okay? I think everyone here that has done anything with technical writing and any writing whatsoever or doing presentations is the first step is to consider your audience, right? Where are they? Who are they? What do they need? How do they process information? What information and skills do they already have? And so on. As you write, it always starts with what understanding your audience. Now, for a report that's going to go out into a large audience is you need to focus on the key decision makers that are using that information to say, oh, we need to do that accelerated life test, or our product is going to survive with a reasonable failure rate out to 5 years, so we're good, or not. What decisions are they hoping to make, and how does your information help them along on that path? That's part of understanding the audience. Now, the other part is that when you're doing a presentation or a report, it often gets shared with a wider group, right? Not just the decision makers, but other people need to be made aware of this information or need to consider the information you're providing. Again, it gives you the opportunity to define terms, to present background information, to do teaching in one form or another. Now, live presentations that's the question and answer section, right? They're going to ask questions. They're going to look confused. They're going to give you those opportunities to teach. And in written reports and presentations, you have to anticipate that. What parts of your process or of your presentation or your report needs to be explained or have background information supporting it? Now, the caveat is not everything does, right? Oftentimes with written documents, we're going to create an executive summary. We're going to create just the highlights, the key takeaways, the main points, and for those interested, here's all the details and background. If you bury that essential information, in today's world, and even the world 50 years ago, you're going to lose your audience. They're not going to read further down there because it's what's in it for them, right? What are the key elements that they need to make a judgment on or make a decision about? And if that's not obvious, you lost them, right? And that's just basic presentation and reporting skills. Yet from a teaching point of view, a good practice is always make sure that you're easily identifiable as available to illuminate or expand or answer any questions. The great presentations and reports anticipate those salient elements and explain them. So if you're doing a presentation about wanting to start using physics of failure modeling instead of accelerated life testing, well, you may well need to explain one or both of those concepts and how they relate and how you can move forward from that, how you are changing the ability of those people you're working with that use that information to make decisions. And so it may require some more teaching. If you just say, all right, physics of failure is better, let's just use that, it may be a non-starter, right? If they don't know what you're talking about, it's hard for your audience then to make a decision. And it's easier just to say no in those circumstances if it's not understood. So across, whether we're doing individual one-on-ones or in small groups with like a team meeting or a small meeting, or in a more formal setting when we're doing a presentation, say whether at RAMS or even at in our organization, we have the opportunity to teach, right? And I'm sure there's other ones. So what other areas do you find? And I saw a number of folks that are talking about, you know, they have an internal university and they actually are teaching classes, or you're at a conference and you're presenting there. So I think I covered a little bit of that. How else are you called in to do teaching? What are some examples that you can think of? Problem solving. Yeah, and Michael, that takes on so many different venues. I was just working with a team that um, we were told to go start off on an 8D process, eight disciplines of problem solving. So we get together and we sit down in the room for the first time. There's three of us there, and one guy just rattles off, "Oh, I know the answer to this, and why are we spending our time in this meeting? Let's just knock this out and get done with it." Now, he may or may not have been right, right? But when a complex problem occurs, it's usually a good practice to understand the problem first, and let's see if we can replicate it and understand what is the root cause of it before we start slapping on, and I'm using that loosely, but we start applying what we think are the solutions. And so it was an immediate point to say, well, let's think this through a little bit. And that's a teaching moment. Excellent. When we're planning, we're doing strategy, risk assessments. Oftentimes and Cheryl, I find that is a great example for teaching because it's like an FMEA where there's different views of the same system, and our views don't always match. So here's what I see and why. Here's what I see and why. Now, the teachable moment is one in explaining and discussing the differences and why we see things differently. It also is why is there such a gap? And then what's the resulting issues there? Yeah, explain your numbers. Yeah. So Jay, it's back to calculus then for you. Yeah, lots of different circumstances that we run into where we're teaching. A part of what we do is teaching. And let's see a question down here. Let me expand it. Dan saying, I find that most people are more interested in telling what they know about things and are less interested in listening. Yeah, that's the emphasis of this first three couple of topics here is know your audience. And the best way I know how to do that is to not be talking, right? Asking questions, listening. There's a whole field called active listening. And getting good at that is a way for us to learn. Part of it is also what is the actual issue or problem or element that needs to be clarified or resolved or understood. Where's the gap in understanding that we may be able to help with? Or is that gap in understanding on our side, right? Let's understand that also. All good. All right. Now there's tons of different ways to teach, right? Teaching methods, and there's the formal classroom lecture, blah, 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 sort of like this webinar at times. I try to add more comments and questions in there. Yet part of this is a technique called guided discovery. How do you set up the scenario of helping the student discover the information for themselves, create the information they need to make it happen? This is not always possible, but it's a technique to keep in mind. But if somebody says, hey, we want to do physics of failure, or they get confused when I mention, oh, we're going to move to a physics of failure model for this application. And they look confused and they ask, what is physics of failure? Right? Now, if I only give them a very brief element of it, I just provide a definition. That may or may not be something that sticks with them, that they take away and actually understand. But if instead we say, you remember the accelerated life testing we did and the mathematical models we use? And they go, yeah. Well, how about the physics of failure is a different terminology for this, but it allows us to do some of the same things. But what if we could use the models and not do the testing, or do very limited testing? So I may be confusing this with a little bit of the next technique, but it's if we provide just enough information so that they can ask the next question or go, oh, okay, I get it, or that they see the next step and then can go on from there. That's what I mean by guided discovery, is we don't provide the complete PhD level, 60 hours of classroom lecture about physics of failure modeling for every conceivable failure mechanism. We provide just enough to move them forward so that they then can build on that and discover the value or the answers for themselves. So a short way of trying to say that. Another one is the Socratic method. And this is where you are teasing out the information using good questioning. So you don't provide the answer. I used to work for a boss, and she was brilliant. She'd come by and say, "How's it going?" And I'd say, "Oh, I'm doing this, this, and this, but I'm struggling with this part." And he goes, "Have you looked at it this way? What's the primary target for those people? What's the obstacles that you're seeing? Have you thought about any opportunities to look, for these ways to solving that problem?" She never told me what to do. At least it never felt like it. But she always asked a handful of questions to the particular issue that helped me see a way forward. That she made me feel like, and she was a master at it, is that I already knew the answer. I just had to pay attention. And she helped, whether it was guided discovery or Socratic method, it was brilliant. I thoroughly enjoyed the process, but it was more of an exercise in how to think through a problem rather than here's the answer. Now, oftentimes I get asked the question, especially for like drop testing or environmental testing type applications, well, what's the standard for this? How do we design this test so that it's useful, right? So for drop testing, the standards say drop it X number of times from a certain height onto a certain material, and if it doesn't fail, you're good. Well, we all know that that's not necessarily useful and nor accurate in most of the cases. And so the idea of saying, well, what is it we really need to know, right? Well, we need to know if it will survive. Well, what's one way to tell if it survived? Well, and then Socrates would ask these questions that would basically lead his students to answers. And I've gone through this a number of times, is that what we really need to know is when will it fail? How high of a drop, or how many drops, or what kind of damage occurs when it does fail? And what kind of margin do we have? And by leading a person through the rationale of that's what we really need to know, then the test plan becomes obvious, and they can go do it. So it might be a mixing these two methods a bit. Right. And Ben, you're exactly right. The idea with these methods and for teaching is not to say, oh, we're going to drop it 10 times from 3 meters and it'll be good. It's, well, what's the rationale behind that? How do you create for many of things that we do, we need to create the understanding so that that information can be used and will be accepted and understood. But by covering why we got there, or how we got there, or why it's important to them, all of those elements then, one, focus on what's in it for your audience. What do they need to know so that they can do their job better? But the other piece is to let them develop that logic structure or that way of thinking that allows them to answer similar questions going forward. So it helps them in the moment and then in the future. Now, a little bit different method, and this is what I find when people are really, really busy, and it is, let's say, a longer process. If somebody wants to set up an accelerated life test that you know is going to take them 6 months to accomplish and probably 2 months just to get set up, it's probably not a good time to talk about all of the detailed reporting that you need to do at the end of the process and error checking and all those other things. Let's back that up by, here's the big picture, that's useful to have, but what is the first step I need to do? And for like accelerated testing, I would say, well, what's the failure mechanism? What is it we're testing for? What is it then that leads to the stresses that we need to use? We get that sorted out, then it's, well, how well do you need to know the answer, or when do you need to know the answer? And so instead of saying, well, here's the 57 steps to set up and run an accelerated life test, let's get started with, well, here's the first couple of steps, and that's just to get started. I'm working with a client right now that it seems like every Monday I get a new email from her with all right, here's where we're at now, and this is what I think we need to do next. And sometimes she's got it, right? And sometimes it's, well, how about this? Think about it this way. How does this impact your next step? And so it's just in time. Oftentimes when we're working with a team of people, and if you're lucky to have other reliability professionals nearby, and it allows us to, um, meet them in the hallway, or we're just past each other at lunch, or we can ask a quick question as we have time and the opportunity, and you have the opportunity to teach them the next step, just the next piece. And it's really all the time you have for it. If that works for your audience, it's a great technique to keep them moving, continuously build the trust that you're the go-to person, and help them solve their problem, right? If you have the opportunity and they're interested, you can take them through a more structured course, an overview and details about um, the whole process of setting up an accelerated life test, right? But we're not always taking people into the full course, right? So that doesn't always work. Sometimes we have to do just what they need just now, and then move forward from that, right? So I probably mentioned this 6 or 7 times already, maybe more, we have a lot we can teach, right? When I sat down a few years ago to think about these webinar programs, I thought, oh, here's 40 topics. And I've done, I don't know, 60 or 70 of these webinars so far, and I'm still not running out of topics. Many of these topics, though, come from the audience. I ask regularly, I get feedback, I get questions regularly, and that forms the genesis for these topics, to expand on them. One is I answer the question, and then 2 is I can build on that to answer the question for other people. But the key part is to focus on what that person needs and adjust the timing, the length, the duration, the style, the technique of how you answer that question for them. Now, if somebody comes to you and asks, what's a good reference for accelerated life testing? I want to know everything there is to know about it. Now you have a bit more flexibility there, right? You don't need to teach them all yourself. You can say, oh, here's my 2 or 3 go-to references, and let me know if you have any questions. I'd be happy to talk to you about it, right? Which allows them to, 1, answer the direct question, but 2, gives them the backup of these are, it's open for discussion. There's things in here that you still may have questions about. Let's continue the discussion. So it's, the focus, I find, is that even though we have so much to teach and so much that we can convey, and so much also that we need to learn about our business and about our product and about its technology, the key part of our teachable moments is recognizing and matching what we provide to what they need. And that's, I hope, is going to be the key takeaway from this discussion. All right, so how have you seen it go wrong? And I think I saw a few in the chat window already, and I've mentioned a few of them already. And I just saw a question from Cheryl. The slide deck is made by Adobe Captivate, and it saves it in some funky format within Adobe PDFs that you need the Adobe Reader, the current version of Adobe Reader, or the current version of Adobe Acrobat to see it in its the way it shows up on the screen here. It has a bit of animation built into it, and so some PDF viewers don't have the capability to show it correctly. So that's most commonly what happens when you see the one blank slide. So hopefully you can work that out. And let's see. So what have you seen? How does teaching go wrong? Yeah. What do you mean, Michael? Extend the appreciation beyond understanding. Is it like Jay going into the calculus derivations or something? Or yeah, more detail than needed. Yeah, and that's why I stress this is answer the question, help them move forward, and then stop. Make it. I think it's answer the question. If they smile or nod or got it, that's your cue to just say, all right, good, we're there. The other technique is to regularly check in. Is that helpful? Did that make sense to you? Are you good to go? What else do you need? Is a cue of whether or not you're there or not. Yeah, yeah. Oh, yeah. And I remember those courses. And read the next 600 pages, and there's a test on it tomorrow, kind of things. So yeah, Micah, you're in college, so you probably are feeling that pain at times, I'm sure. Um, yeah, there's a lot of information out there, and every day we're creating more and more of it. The real gist of teaching is teaching just enough, and I've learned this through experience, and I've been taught it over and over again. Yet it's one of those things that it's really that focus on what does your audience need. That is not what you need. Yeah. And Brian, you're exactly right. Not in the language, not just, somebody's speaking in Swahili and I only know English and a little bit of German. It's that they're talking with assuming that I understand the terms they're using and how they're using it, right? Sometimes it's just definitions and basic understanding of the different technologies. If I go talk to an electrical engineer about ASIC design, there's a whole different language to that versus what I talk about with failure analysis and failures of ICs. Now, we have to be able to talk to each other, and at times, even just the term reliability has different meanings to people. It's one of the first questions I ask the graduate students in the courses I teach. How do your customers define reliability? And it's often different than what we do as reliability professionals, right? So be clear of the terminology used. Again, speaking the actual same language actually helps a little bit. And then more nuanced is the same technical language. Be at it where they are, right? Yeah. And you're right, Jay. We're not trying to make everybody a subject matter expert. We're trying to help them move forward with their expertise, incorporating the reliability stuff that we can often provide and that they are asking us to deal with. Now, if you're dealing with consulting, and many reliability professionals are essentially consulting within their own organization, right? You're influencing other people and teams to make decisions, right? Whether it's to run an accelerated life test or understand the ramifications of the results of that accelerated life test. Now, we have a couple different ways that we work as consultants. One of them is called pair of hands. And the best way to think of this is that you roll up your sleeves and you go do the analysis on the, you set up and run and do the accelerated testing, or you're working with the vendor directly to understand the failure mechanisms, right? You are doing the work, right? And then it's helping other people understand what you're doing. If you're working, say, with a vendor and there's a reliability issue, and you're working side by side with a supply chain engineer, somebody that has the technical skills to understand that technology, yet they need to be good at reliability. A great way to do that is demonstrate it for them, saying, all right, let me join your team, let's go talk to this vendor, let's work through the issues, here's the analysis. But as you do that, is be aware of jumping too far ahead and making conclusions that they can't follow, right? So tell them what you're thinking, tell them the considerations, show them how you analyze the data, show them how and why you ask the specific questions. Now, if you've got a student that's interested in improving their ability to be a supply chain engineer, by incorporating the reliability practices in it, that's a pair of hands approach may be really appropriate, because you can show them live, solve today's problem, and teach them how to solve and prevent future problems, right? Is an example of pair of hands. It's not just do it yourself and show them the results. That's not teaching, but demonstrating it for somebody else. This is how you do it, and making the stuff that's inside your head visible or available to the other person helps them do what you just did, right? With experience, then they can get really good at it. Another approach is you are seen as the subject matter expert. You're that person, right? You're expected to come in, assess the situation, say, go left, not right, and you'll be fine. Here's the biggest danger is that you're going to try to create, I think it was Jay that mentioned, is make them the subject matter expert also. That's not what they want. They want the expert to come in and help them make a decision. You need to tell them what were the critical elements that sways the decision from right to left or left to right. And that's it. Move on. Answer their questions, meet them where they are so that they understand enough that they understand your recommendation. And that's it. Move on, right? Subject matter expert is a role that many of us play, is a reliability professional, right? We're asked, so what's the risk here? Are we ready to ship? What's the interpretation of all the modeling and estimates that you've been doing? But just saying, oh, there's lots of variables, and then go into dissertation about all of the ways that this could be not the right answer. No, answer the question. Here's what we know. Ding, ding, ding. The product's ready to ship, and there's going to be these 3 risks that we need to monitor. You can say that in 5 minutes, right? And then respect that you're talking to intelligent managers and engineers that are looking to you as the expert. And so if they have questions, you should be able to explain it clearly in a way that they can understand and make an assessment of, yes, this makes sense or not. The hard part is you have the burden of too much knowledge, right? You know too much. And so I get this all the time is somebody says, well, how many samples do I need? Well, it depends, right? That's not an answer though. So what are the 2 or 3 things that dictate what sample size you need? Let's explore that. Let's ask a couple of questions and teach them to frame that question of, well, how many samples do I need, to a better question about, giving these considerations, is 3 samples enough? Right? Which is a whole different question than how many do I need. So the subject matter expert can use many of these other teachable skills and approaches to help your audience, one, ask better questions of the subject matter expert, but also reinforces that your command of the topic, such that you can help other people appreciate the complexities and still get answers and find resolution for it and improve how they do their job. The third approach is the trusted advisor. You're the sage at the top of the mountain, essentially, right? They come to you saying, all right, you've not steered us wrong in the past. You've got a great track record. Here's where we're at today. Here's the situation. You've been gathering and assessing this information. What do you think? Is this the right strategy? Is this the right warranty policy? How could we improve our failure analysis process, right? Usually it's building on that you know what you're doing and you can help other people do it, that pair of hands, that you've gained the trust and recognition of your peers that you're the subject matter expert and they listen to what you say. And then the trusted advisor is building on those 2 elements, if you do them well, that they come to you with strategic questions. They come to you with, help me focus and solve this myself, but I need your guidance or your advice, right? Each approach can be used in many different circumstances individually, yet trusted advisors usually only appropriate after the first two are demonstrated and seen that you become the trusted advisor, right? You don't just put out a shingle saying, I'm the trusted advisor, only ask me good questions. Well, you got to earn that. You got to teach your organization how to use that approach effectively. It doesn't always work. Yeah, a mentor to the team is a great way to think of a trusted advisor, right? You got to earn that in a large degree to make that work. And so 3 different methods for doing that. All right, how do you pick the right approach? All right, this might be considered a trick question, but what do you think? What's the right way? If somebody asks a question or looks confused or obviously needs a bit of information that you have, how do you determine what to do? How do you respond to that? Send your whole team off to get a PhD in reliability engineering? That might be a good way to go. Yeah, you know, Sean, one of the things I've learned over the years is oftentimes the question that is asked is not really what they want to know. It's not what they need to know, it's what they want to know. Right? How many samples do I need? And if you drill down on it a little bit, there's usually a question in there that they're trying to use those samples to answer. So it might be, what's going to fail first? Well, 3 samples is probably fine. If they want to know, will 98% survive for 5 years? Well, 3 samples may not be enough. Let's understand what it is that they really want that generated the question they presented you with. Oftentimes, a few questions of your own will help you understand what is it they really want, and peel that back a little bit so you can answer both questions instead of just the presenting questions. If somebody insists that I don't need to know anything else, how many samples do they need? Then I say 648, which usually starts with, well, that's impossible. And then it says, well, what is it you really need? And so I might be a little flippant on that. More mostly because I've seen it way too many times. Yeah. Good. All good stuff there. All right. So I'm going to highlight just a few things for you to continue. I'm going to move over to the conclusion view of this because it has the links. On the lower right-hand corner, there's a whole list of links for books, for TED Talks, for mostly books that I'm going to mention here in a moment. But one of the things that we need to do in order to be good at helping our organizations create reliable products and systems is our ability to teach. Now, the trick is not just to answer questions and be helpful and add value, is you need feedback. In order to get really, really good at something, is that it's this, what did they, Gladwell, or Malcolm Gladwell in his book Outliers talked about 10,000 hours, but it wasn't the 10,000 hours to get really good at something. It was that you got feedback. Right, that you had a coach, so to speak, that said, that was good, and you need to focus on this part. Or when I was learning how to swim, it was not how to be an Olympic swimmer in the first lesson. It was, how to breathe in the water and to put my head down and what that did to my posture going through the water. And then it was what to do with my hands, and the next step was, and so on. The coach that I had, the advice I was getting was assessing where I was at that moment and then what I needed next. And she got the feedback because she could see the performance in the pool. right? Could see what I was doing well and not well. With reliability and engineering work, it's often you have to ask. You have to, did I answer your question? Did that work for you? Another way to get feedback is, especially if you're doing a presentation, is ask somebody you trust to not listen to the presentation, but to watch you in the audience of what's working and not working, right? Ask somebody to give you feedback on your performance, on your ability to interact with that audience and help them walk away with the key points of your presentation. Get the feedback. That's the key piece of this, right? As you practice teaching, always look for that feedback. Now, reading about it, there's articles and blogs. If you just search for how to teach or teaching tips or hints or teaching methodologies or so on, millions and millions of pieces of that. In the links, let's see, where did it go? There was an article called The Secret to Student Success. And it was really, I thought, it's not that long, and it's a well done short article, but it was essentially focused on teach them to learn. It's not teach them 1 + 1 = 2, but how do you learn math? How do you apply this? Where do you use it? Most of the folks we're working with are engineers and well-trained engineers and managers. And they've been in lectures and classrooms a big portion of their lives. In our teaching with them, it's often building on that foundation and reminding them of stuff they should already know or helping them recall that, but also more importantly is putting together context in framing so that they can ask and answer their own questions more effectively. Now, there's a magazine I follow, and they have regular webinars, and it's called Training Magazine, and it's for the professional development world. It's for the corporate training market, essentially. Yet they do talk about everything from classroom training and online training, but also they do a lot about how people learn. And so they have a free webinar series that I regularly attend as often as I can. And I've run into people like Carmen Simon, who's a psychologist, I think, by training, but she wrote the book Impossible to Ignore. And it's an interesting text on how to help people remember something from your presentation or from an engagement or for training with them. It goes into a lot of details about how to be noticed and effective and something that takes away. And one of her key points was, we're talking to somebody today in the hallway, yet they need to remember it when they're in the laboratory next to their test samples. So how do we trigger that memory for them when they're actually in the circumstance when they need that information? That was an insight I hadn't thought of before. Not many people have PowerPoint and a lecturer standing next to them when they actually need to use that information. So think about that a little bit. And Carmen's book goes into a lot more detail on that topic. Many of you have heard of Nancy Duarte and the Duarte Company. She's written Slideology and Resonate, 2 excellent books about the art of presenting or being persuasive. Another author you may not have heard of is Robert Cialdini. I think that's how it's pronounced. And he talks about influence and persuasion. So part of teaching oftentimes, especially when we're helping people come on board with a proposal that we're making, is how do you influence them? How do you trigger a response in the direction or the way you want to go? Now, those books are written really for marketers and people making commercials or ad campaigns or trying to get you to buy something. Yet, a lot of what we do is trying to influence people to help them understand the impacts of their decisions on the reliability world. And so a lot of the elements in those books are at play for us on a day-to-day basis. And finally, a TED Talk that's on, if you want to be great at something, the whole premise was get a coach. And going right after that, a trusted advisor or subject matter expert type approaches. And then there's courses. One of the best, and I'm going to leave it with this one, is Learning How to Learn. And Barbara Oakley is the most viewed MOOC, massive open online course or online open course ever. And it's fascinating. And she does an amazing job of helping the students, the people that take this course, understand, one, how to learn better themselves, but also to how to help other people learn. And she goes into some brain science, she goes into some basic practices, she goes into tips and hints that I've gone through the course 3 times now, and I'm still learning stuff for it. And there's tons and tons of stuff on Coursera and edX, lynda.com and others on how to teach. And so there's lots of information out there for you. So how else can you get better at it? Practice, I guess, is the bottom line. Just try. There's lots and lots of resources out there for you. And so, quick summary, right? You know something, you have some information, you have some knowledge, you have some insights, and you've run across somebody that would like to know what you know. That's a teachable moment. That's an opportunity for you to convey what you know to somebody else to help them be better at what they do. This is not for you to be better at what you do. Teaching is to help somebody else move forward, to add value, to be more successful. The benefit is they come back to you and ask better questions. They ask over and over again, right? And you become a valuable part of their success. And that's a good place to be in. So with that, let me wrap this up. I've gone over for a couple of minutes. Appreciate that. And we had a really good turnout. I really appreciate that. Lots of questions in the chat window. And I'll stick around and answer any questions that are outstanding or whatever I can do in a moment. Next month, we're going to talk about pending the NOAA website still being up. The last government shutdown shut down access to the site. So I'm hoping it stays up so I can gather what I need to do this webinar. It's on how do you use the available weather climate data in your work, especially when we're dealing with like environmental testing and such. And I'll show you how I use that data to great effect. So everybody's saying thank you. Appreciate it. Very welcome. As you know, I love talking about this stuff. So how do you teach designers that have a big ego and think they know everything? There's a hard part there, is not saying I told you so. Oftentimes they're looking for solutions when there's a problem. But oftentimes, I find that a way to teach somebody in that realm is what's in it for them. How can they be better at creating a successful product or create a successful system? And highlight that, hey, if it fails in this way, and here's the evidence that shows half of them are going to fail in 3 months, you might want to address that. Right? It's not imposing it on it. They have that ego. They know everything. Well, maybe they just need another view that helps them see an opportunity to and they won't admit it, that they're learning something. And in some cases they do. They turn around and become your biggest supporter. But it's a trickier dance to understand what is it they need to know in order to be really successful. And oftentimes it's their own success that's of highest priority to them. So tapping into what they deem important and then bringing that teachable moment to them in that regard has been the only technique I really know about. Let's see. Yeah. Yeah, and Goodwin said, bring up past scenarios. If you can improve the success rate and say, instead of 2 out of 10 were successful, let's get it down to 1 out of 10, our pad, that it may build on that. I found sometimes they don't want to talk about it, and they'll have plenty of excuses why that wasn't their fault. But it is a technique that has worked.